Hello and welcome. In this lesson, we will learn how to multiply a vector by a scalar. I promise it's going to be a fun lesson and very easy to understand. So as you might have gathered at this point, a vector can be multiplied by a scalar, which means we can multiply a vector by a number. Further to this, we will discuss some of the properties of vectors that derive by this multiplication. So let's get started with the rules or definitions. So if k is a real number or a scalar, then k times vector v is a vector where the magnitude of vector kv equals the magnitude of k times the magnitude of vector v. Now, if k is a positive number, kv will be in the direction of v. What does that mean? Suppose that you have some vector v here, and you're multiplying vector v by some number, for example, 2. So that means k equals 2. If you multiply vector v by 2, it means that you're making vector v 2 times longer. So the magnitude of v will be twice as big. The direction, though, will stay the same. So this will be vector 2 times v. Now, if k is a negative number, then vector kv will be in the opposite direction of v. So, for example, again, we're referring to vector v here, but this time we're going to let k equal negative 1.5. So that means that the length of vector kv will be 1.5, the length of vector v, and the direction will be exact opposite to vector v. So this would be negative 1.5 vector v. Now imagine k being 0. If you multiply anything by 0, then it will give, the answer will be 0, which means that if we have a vector v and you multiply it by 0, then we'll get just a dot. Now, the 0 vector has a length of 0 and has any direction. So this is how we perform the multiplication of a vector by a scalar. Now, let's take a look at the properties, which are again quite intuitive and very similar to what we do with polynomials. So if you have some scalar k multiplying the sum of two vectors, then the answer will be ka plus kb, where k again is a real number, a and b are vectors. Also, if we have a vector multiplied by the sum of two numbers, that would be vector a times the first scalar plus vector a times the second scalar. Now, if two vectors are parallel, for example, vectors u and v are parallel, it means that we can express vector u in terms of vector v. For example, say that we have vector u here, and we have some vector v. And they are two parallel vectors. I'm going to make v a little bit longer so it's a little bit more interesting. So this is what I'm going to do. Let's give it a name. So I'm going to place this vector u right on vector v. They are kind of parallel, right? So we have one vector u, two vector u, three vector u and a half. So we're going to say that vector v is 3.5 vector u. So if two vectors are parallel, they will have the same direction, which would allow us to express them as scalar multiples of each other, because scalar multiples of a vector maintain the same direction of a vector. Now, let's take a look at a fun exercise on GeoGebra. So I prepared this lesson, and hopefully it will make sense. And here we go. First, I want to explain you the diagram a little bit. So we have vector u, the green one, and vector v, the blue one. For vector u, we have a slider a. So notice that when I change the slider, move the slider a, vector u changes the length. Now, remember that vector w is the sum of vectors u and v. So when I change the slider of vector u changes and also the sum. Now, slider b changes vector v. So when I move the slider, you notice that vector v will change, and obviously the sum of the two vectors will change. I'm going to make the sum of two vectors invisible for a moment, because I want us to see how each vector works. And I will also make vector v invisible. So let's move the slider of vector u. So here is vector u getting longer. That's because a is bigger than 1. And I'm going to make vector u, or I will multiply vector u by the scalar 0. What happened? Oopsie. So vector u became vector 0, so we only see a dot. Now let's make it negative. So when the slider or the coefficient or the scalar is negative, vector u is going in the opposite direction. So it's on the same line, but opposite direction. Now let's bring vectors v or vector v back to life. So the same thing will happen with vector v if you move the slider. So vector v, slider is at 3.2, so it's longer, 3.2 times bigger, and then here is v0, and here is v negative. Now the sum of two vectors will change along with the size of the vector. So here we go, and here we go. Right, so vector w is the sum of the two vectors. So with this, I hope that we can imagine now how the scalar multiplication changes the size of a vector and the direction, obviously. So let's take a look at some examples now. An airplane is flying in the direction north 30 east at an airspeed of 240 kilometers an hour. Now we have to draw a sketch of negative 1/3 v and state the direction of the vector. So first I have to decide on the vector 250 kilometers an hour. So I'm going to start off with drawing the compass. And here goes north and south, east and west. And vector v is heading north 30 east. What that means is from north line, we're going 30 degrees towards east. So here we go. And there is vector v. This looks like a 30 degree. Again, we're just eyeballing it. So the angle is 30 degrees and the velocity is 240 kilometers an hour. Now, if you want to draw vector negative 1/3 v, it means that the size of this particular vector will be divided into 3, and it will go in the opposite direction because negative 1/3 is negative number. So here we go. So continue the line in the next quadrant and make it 1/3 of vector v. Sorry. Just going to name it negative 1/3 vector v. Now, for the vector 2/3 of the vector v, we have to state the direction and the magnitude. So now, if you want to draw 2/3 v, it means that we are staying in the same direction as vector v because 2/3 is a positive number. And that means that the only thing that will change is the magnitude. So if you divide this into 3, then this would be the vector. And let's make this a fun color, purple. And here we go. This looks like 2/3. And this would be 2/3 v. And the direction of 2/3 v will be the same as vector v, which is north 030. That's a more proper way of describing it. East moving on to the next example. We are given two vectors, u and v. Vector u is 8 and vector v 5 units. Here they are, u is 8 and v is 5. Now the angle between these two vectors is 30 degrees. So here we go, 30 degrees here. Now, we have to find the following. What is the magnitude of vector 2u? So the magnitude of vector 2u would be equal to twice the magnitude of vector u. So that means 2 times 8. So the magnitude is 16. What is the direction? We're going to say same as vector u. So at an angle of 30 degrees with v. Now, what is the magnitude of vector 3v? So the magnitude, negative 3v, sorry. So negative 3v must be 3 times longer than vector v and going in the opposite. So negative 3v magnitude equals negative 3 times magnitude of v. So magnitude of negative 3, absolute value of negative 3, right? So that would be 3 times 5, because vector v is 5, and that would equal 15 units. Let's write units in here. So we express the answers in proper form. So the direction will be opposite to vector v. Now, we have to find the magnitude of 2u minus 3v. So this is going to be fun. So if we want to find the magnitude between 2u and 3v, we're going to draw a diagram in here. Now, vector 2u will be about 16 units. Now, negative 3v will be about, I'm going to bring vector u here. Vector 2u. And here we go. We're going to put the vector negative 3v at an angle of, now remember this is vector v 30 degrees, so negative 3v will make an angle of 180 minus 30 or 150 degrees with vector u. Let's bring the purple back. And I think that it will be useful to move the diagram a bit. The vector here, so that we have more room for our vector negative 2u. Negative 2u, and that's negative 3v, which is about 15 units. So slightly shorter than 2u. So this is negative 3v. And the angle in between is 150 degrees. Now, we have to find the magnitude 2u minus 3v. So you can look at 2u minus 3v as the sum of vectors 2u plus negative 3v. Which means that we're adding vectors 2u and negative 3v together. We're going to use the parallelogram rule since they're already placed tail to tail. And we'll say that the resultant vector will be the one that comes from the two tails, from the connected tails towards the opposite vertex. So let me make this parallelogram look nice and neat. Now we have a few calculations that we want to perform here. So we have this side equal to 15. Now we have this one here equal to 16. This angle, which is 30 degrees. And here goes our vector 2u minus 3v. So in this triangle, we need to find this side when we have 15 and 16, the other two sides, and the contained angle. So the magnitude of 2u minus 3v can be found by using the cosine law. So we'll write this down. 2u minus 3v magnitude to the power of 2 equals the magnitude of 2u squared plus the magnitude of negative 3v squared minus two times 2u times negative 3v times cosine of 30. So in other words, we'll say 2u minus 3v magnitude squared equals, remember 2u has a magnitude of 16, so that's 16 squared, plus negative 3v has a magnitude of 15, so 15 squared, minus 2 times 16 times 15 times cos 30. Now calculator, and that will give us the value of 2u minus 3v squared, obviously. So 16 squared plus 15 squared minus 2 times 16 times 15 times cosine of 30. Remember to set the calculator to degree mode. So the answer I got is 65.3. Now I need to square root that answer to find the magnitude of 2u minus 3v, and that would be 8.1 approximately. So 2u minus 3v in magnitude would be 8.1 units. Now we have to determine the direction of 2u minus 3v. So to determine the direction of 2u minus 3v, we can look at the angle that 2u minus 3v makes with either vector negative 3v or vector 2u or vector v itself. So I prefer that we find the angle that it makes with vector u. And I'm going to mark this by some letter theta. So remember that in this triangle here now, we need to find the angle theta, and we know the following. So we know this side here is 15, this one here is 16, and 2u minus 3v, which we just found, is 8.1. We also know that this angle is 30 degrees. That's the angle made between the two vectors, and remember, this is a parallelogram, so the opposite angles are equal to each other. It seems that this calls for the sine law, and we're going to write 8.1 divided by sine of 30 equals, remember, this is what we're trying to find, angle theta, so we have to include it in our equation. Opposite theta, you have the side 15, so 15 over sine theta. Cross multiply. And now we have 8.1 sine theta equals 15 sine 30. You know, sine 30 is 0.5. If you don't, calculator can do the work for you. So sine theta equals 15 sine 30 divided by 8.1. From where theta equals inverse sine, 15 sine 30 divided by 8.1. I like to do the calculations in one step to ensure accuracy. So 15 times sine of 30 would equal 7.5. Divide that by 8.1. That is about 0.9259, but we're not going to write that number, just simply put that number inside inverse sign, and that will give the answer for the angle, which is 67.8. So theta is 67.8 degrees. So we're going to say that 2u minus 3v makes an angle of 67.8 degrees with vector u. Now, let's take a look at some properties of vector addition and properties of scalar multiplication, etc. So this is just a summary. Recall that if you add two vectors, the order won't matter. We say that vector addition enjoys the commutative law. If you add the sum of two vectors to another vector, then we can rearrange the vectors a plus b plus c. So this is the associative law, so we can group the vectors in any order we want or we wish, and we still get the same answer. This is the properties of scalar multiplication. That's the associative law, which means mn times vector a is m times na. Remember, m and n are scalars. A scalar m times a plus b is ma plus mb. We talked about it at the beginning of the lesson. And m plus n times a is ma plus na. Now, vector a plus 0 equals vector a. We saw that in the first lesson of the unit. Each vector a has a negative or an opposite negative a that add to 0. And this is something that we haven't mentioned yet. It is called the triangle inequality. So if you have vectors u and v, the sum of these two vectors will always be less than or equal to the sum of their separate magnitudes. Remember that two vectors will always make some angle with each other. And no matter what the angle, this sum will never amount to something bigger than the vectors u and v added together. Now, the smallest this sum can, or the largest this sum can be, is when vectors u and v, so the blue and the green vector, went in the same direction. So if the two vectors are parallel to each other, then u plus v magnitude would equal magnitude of u plus magnitude of v. And you can tell this by simply placing this vector, or these two vectors, head to tail. Okay? Other than that, the sum will always be a number, or will have a value less than the sum of the two vectors separately. So we have some practice questions in here where you have to sketch the sum. These are fun exercises. You can do that on your own. You're given vectors a, b, and c, and you have to find the sum a, b, and then you want to add c to the sum that you find. And then you want to find the sum b plus c, and then add the vector a to b plus c. So the idea behind this is that we want to prove that these two vectors would equal the same vector. So I can easily start off in here by, let me just copy these vectors. And I'm going to start off with vectors a and b. So I will grab them. Here goes vector a, and here goes vector b. I'll place them head to tail, and the sum a plus b would equal, based on the triangle law, this one here. Okay, so this didn't work out very nicely this way. So this would be the sum a plus b. So if on a plus b we added the vector c, which is 2 units, then the resultant will be, I'm going to make the resultant color orange. So this will be the resultant vector. So this is A plus B, and then plus C. Now, in the same way, we're going to do vectors B and C. So here goes vector B. Let's drag this. And here goes vector C, which is 2 units. So adding B to C, I place them tail to tail for parallelogram rule, just for the fun of it, because why not? And we'll say that the vector B plus C will be this one here. Here we go. So B plus C. Now on vector B plus C, I'm going to add vector A. Now vector A is this green vector. Let me drag it. And now I'm going to add vectors A and B plus C. I'm using parallelogram rule here. And let's take a look at what we get. So this will be the vector B plus C plus A. I want us to compare these two vectors, so let me highlight them. So here is vector B plus C plus A. This is A plus B plus C. So as you can see, if you were to count them, we go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So it's the same.